Okay, so the question is, given f of t, a function in terms of t, you need to find f of s, which is the Laplace transform of f of t. This is the notation of Laplace transform, L curly bracket f of t. It is read as Laplace transform of f of t, which is f of s. And we know definition of Laplace transform is integration from 0 to infinity. Whatever function we are trying to take the Laplace transform, we need to multiply that with e power minus st and then integrate from 0 to infinity with respect to t. But we actually don't need to integrate anything to find the Laplace transform of given function, because we know the list of Laplace transform of basic function, which is such as numbers, constant terms, exponential terms and trigonometric terms. So here we have the Laplace transform of the function, given function is e power minus 2t into sine hyperbolic 4t. So we have an exponential function and a trigonometric hyperbolic function, okay, hyperbolic function. And we need to find the Laplace transform of the product of this. So Laplace transform of product is something else, okay, we need to use the property somewhere else. But here we don't actually need to use the property of Laplace transform that we need to use when you have product. We need to convert, we can convert this function into simple sum of exponential terms, okay. So this function can be converted into simple exponential terms to which we know the Laplace transform. So Laplace transform of e power at we know, right? That is 1 over s minus a. So we need to use this formula to take the Laplace transform of this, okay, after simplifying this to the simplest terms. How do you do that? So we know sine hyperbolic 4t is a sine, any sine hyperbolic theta can be written as e power theta minus e power minus theta by 2. So this is a basic trigonometric formula. So if you have a hyperbolic function of sine with angle theta, it is e power theta minus e power minus theta by 2. So using this, in here we have, in place of theta we have 4t. So I can write f of t as e power minus 2t as it is, just keep it as it is. And sine hyperbolic 4t can be written as e power 4t minus e power minus 4t by 2. Okay. So taking this 2 outside and multiplying e power minus 2t to each term, so then I'll have 1 over 2 e power minus 2t into e power 4t, e power minus 2t into e power 4t minus e power minus 2t into e power minus 4t, e power minus 2t into e power minus 4t. Okay, so this is my f of t now. Now at this point we know a law of exponents, which is if you have same base different power multiplication. So that is a power m into a power n, it is nothing but a power m plus n. The powers get added. If you have same base powers, the powers get added. So using that law, I can write this as 1 over 2 e power minus 2t plus 4t can be written as plus 2t. It is plus 2t. Minus e power minus 2t minus 4t can be written as minus 6t. Okay. So given function is simplified using just 2 formulas. One is sine hyperbolic theta is e power theta minus e power minus theta by 2, and another is law of exponent. We have it is just the 2 exponential terms subtracted. Okay, and we know Laplace transform of exponential function. So f of s can be written as 1 over 2, okay, Laplace transform of the first term e power 2t minus Laplace transform of e power minus 6t. Okay, so Laplace is a linear function, which means Laplace transform of a minus b is same as Laplace transform of a minus Laplace transform of b. And any constant terms, any constant multipliers can be kept outside. Okay, so that is one of the rules. So what is Laplace transform of e power 2t, e power at, 1 over s minus a. In place of a we have 2 here. So it is 1 over 2, 1 over s minus 2. Okay, if you have a here, it is minus a here. If you have 2 here, it is minus 2 here. Minus, in place of a I have minus 6. So it is 1 over s minus as it is. In place of a you have to substitute minus 6. So that will be, there will be 2 minus signs here, which will be f of s is equals to 1 over 2, 1 over s minus 2 minus 1 over s plus 6. Okay. So this is the Laplace transform of this function without actually having to use the property of products. Okay, so even though we have product of 2 functions in the question, we can simplify them using our trigonometry and algebraic knowledge, exponential knowledge, and convert that into just the exponential functions, which the Laplace transform of which we know from the table. Okay, and using that we get the Laplace transform of this function. No need to integrate. Okay, so let's see another question.